page 6. So we have page 6 and 7 to do. So not too bad. Is it only 7 pages? Like that, only 7. Anybody start the assignment from last night?
No.
Okay, well, Steve didn't. Did anybody else? Maybe sort of kind of, okay. All right.
I did question 1. Okay.
That's good. That's awesome. Proud of you. That means you don't have to do question 1 from now on. Okay. Co-terminal angles. So this is where we left our page today. And co-terminal angles are angles that share the same terminal arm. So let's say that angle is 30. Looks more like 45, but I'm going to say it's 30. So we know from our initial arm to our terminal arm, that's 30 degrees. Hey, look, just go with me, Steve. You know I'm not good at drawing. So there's another angle that would share the same terminal arm. So if I started here, I went around all the way, and I ended here. How big is that angle? 390. Because I've started here, 360 is here, and then I've gone another 30. Right. Well, it said 360, I was listening. You know that this angle would be 390 degrees. So they share the same terminal arm, they end in the same place, but if really you added a full rotation in. And when I talk about a full rotation, that just means traveling 360 degrees. So to find a coterminal angle, you either add or subtract a full rotation. And because we've been kind of trained in degrees, we think 360. But yesterday, our world was opened up to radians, and what's a full rotation in radians? 2 pi? 2 pi. So you're going to add or subtract, because we're going to do positive coterminal angles, and we're going to do negative coterminal angles. It's super exciting. Anybody have an idea of what? Use red this time. So using this one, negative we travel in a clockwise direction this time. So starting at the positive x-axis, we're going to travel in a clockwise direction. We're going to end here. What angle measurement is that? Negative 330. Because we haven't gone all the way around yet. We have 30 degrees left to go. So we took the full rotation and minus 30 from it. But because we're traveling in a clockwise direction, we have a negative sign in front of it. So that was kind of yesterday and today all mixed together. Not hard math, but it can be super confusing. Because now we're traveling in clockwise, counterclockwise. We've got radians, we've got degrees, so all this fun stuff. Okay, so find a positive coterminal angle for 60 degrees. All I'm going to do is take 60. I'm not going to minus 50 because I want it positive. So I'm going to add 360 to it. And that's going to be 420 degrees. Is there another one you could do here?
Negative.
Not negative. Could you give me another positive coterminal angle?
Positive 60 plus
780. Because all I did was take this and add a full rotation to it. So this is an answer, but 780 would also be an answer. I'm gonna tell you honestly, if you're doing a test or a quiz or an exam, we're probably just gonna do one rotation. But just know there's some options as well. Like, you see this as a multiple choice question, gentlemen? Where it doesn't give this as an answer, but it gives 780 as an answer. You know what I mean? So,
Find the largest question to go to.
well, that would be maybe something like that, like something that you have to have a knowledge of what coterminal angles are and know that you can add many rotations to it. Yeah?
So are you trying to get like a specific number?
No. You're just saying, hey, at 60 degrees, I'm here, right? So we know that this one's 60. That's where we've lived for all of our lives until yesterday. And now we know that 420 would start here as well, go all the way around, and finish there. Now that's 420. And if we went all the way around again, that's 780.
So that's why you have 360.
That's why we add 360. You add a full rotation. Okay? Kind of makes sense? Sort of, kind of? So 120.
480 degrees.
So all we're going to do is add the 360 to it. Like I said, not really hard math, but can be confusing. Right? Can be super confusing. So like I said, because it's asking you to calculate a positive coterminal angle, probably not a hard question. You're going to stop at 480, you're going to walk away. But it might be a multiple choice question, or say, what's the largest coterminal angle, but greater than 0, but less than 1,000 degrees, then you have to figure out how many rotations you can put in. 560. What do we know right away about 560?
It's already gone multiple.
It's already gone around at least once, right? So you could go 560, and you could add 360 to it. And what do we have? 920. Okay? That wouldn't be wrong. But if I put a restriction on it, saying I want your positive coterminal angle to be less than or 360 degrees, but greater than or equal to 0 degrees. If I put that restriction on it, that means I have to get my positive coterminal angle inside a single rotation. So, is this inside a single rotation?
No.
No. Is this inside a single rotation?
No.
No. But we know it already went around once.
So 560 minus 360.
Yes. Perfect. So if we had this, I would take the, sorry, gotta stand in front of it and then I'll get out of the way. I take the 560 and I take out, or not, I take out that full rotation. So if I wanted to make that where this is more understanding what the restriction is telling me, could I do that with this one? Could I take a full rotation over here?
No.
No, I mean I could, but then I'd have a negative angle, and you don't want that. I couldn't take it over here because we haven't gone full rotation. It's these sneaky ones that already have the full rotation in it. You're going to take it out. Okay? Nothing terrible math-wise there. Positive coterminal angles. Ooh. What does that mean?
It has to be like within the.
Has to be in one trip around the coordinate plane, right? Has to be within 360 degrees. Okay. Do you guys know what a full rotation is?
2 pi.
2 pi. So we know a full rotation is 2 pi. So denominator 3, that would mean a full rotation is 6 pi over 3. You guys would agree with me? Sometimes doing common denominators helps me see it a little bit better. So I know that a full rotation, I'm looking at part A here, a full rotation is 6 pi over 3. It's just equivalent fractions, right? That's all I did there. So, how many full rotations have we done in this one?
2.
2.
Only one, two, right?
It'd be more than 2, but I asked the question, how many full rotations have we done in this angle? And Steve said 2. Because we would have 6 pi over 3, plus another 6 pi over 3, gives me 12 pi. We need to get you a less noisy water bottle. I'm going to find one for you. All right, so we know that 2 full rotations is 12 pi over 3. Am I going to add a rotation to this?
No.
No, because that's going to make a third rotation outside of it. That's not what we want. We want it to be somewhere in that first rotation. So we're going to take our 14 pi over 3, and we're going to subtract that 12 pi over 3, and a positive coterminal angle is going to be 2 pi over 3.
So we're just called up.
That's a coterminal angle. Positive coterminal angle that fits this restriction. Okay. Confusing? A little bit? But it's all about just taking out how many times you went around the circle. If you think of it as a string, how many times did we wrap that string around the full coordinate plane? And in this case, we did it twice. This one's nice and easy. It's pretty nice to see. So this one. And again, I do this off to the side somewhere, especially when I'm learning. If I have a denominator of 6, a full rotation is going to be 12 pi over 6. I just do that to help myself kind of see it a little bit better. So now I have common denominators can work a little nicer together. So really what I'm looking for is, I know this has definitely gone around more than once, right? 103 is definitely bigger than 12, right? So I have to figure out what multiple of 12 is closest to 103 without going over, like the price is right. So if I go down, so what did I have to multiply 12 by?
12 by 8.
12 by 8 gave me 96. So we know from this, we can take out 8 full rotations, which would be 96 pi over 6. So then we're going to take 103 pi over 6, and we're going to minus 96 pi over 6. And how much am I left with? 7 pi over 6. Now to check to see if I'm right, I'm going to look up here. This can only go to 2 pi. The maximum I can go to is 2 pi. This is telling me this is 12 pi over 6 is the full rotation. Is 7 pi over 6 less than 12 pi?
Yes.
So we're good. Still positive. If you went over it, if you went to the next multiple of 12, then you're going to put a negative rotation, and then that's not what the question is asking. There you go. Very handy. Very handy. So if I were doing this and I didn't know the multiples of 12, well, I didn't know them up to 8 or whatever, I know that 12, like I can do 48, right? Like we can all do 12 times 4 and 48. You can take out 4 at a time, or take out 2 rotations at a time, or take out a single rotation at a time. Keep subtracting until you're under that 12 pi over 6. So even if you're not great with the multiples, take out what you know, and then just keep subtracting that one. Because keep in mind, you might not have your calculator for something like this. So if 96 didn't leap off the page to you, maybe 24 might, or 48 might. I don't know why I don't think it's 36, but, you know, like, so you can keep taking that off multiple times until it actually fits the restriction that goes on there. You're going to learn to love restrictions. Maybe you're going to hate them a little bit at first, but restrictions are a huge thing in this course. You need to be able to read them. And when I talk about restrictions, I'm talking about this. It's just saying something really specific about the answer to this question. It has a specific area that I want you to meet. All right. Expressive. Ooh. All values.
That means
Infinite. Infinite. So we have to make a domain statement about it. This is called a general solution. All right.
it's a general solution that is the formula that can be applied repeatedly.
Pardon?
A
Sorry.
general solution is the formula that applies repeatedly.
Pi repeatedly? Yes. So adding or subtracting pi repeatedly?
Apply.
Pardon?
Apply repeatedly.
Yes. Yes. Okay. So what do we know? We are dealing with gradients here. So what do we have to add or subtract from this?
8 pi over
8 pi over 4. But let's not even worry about fractions. What's the full rotation in gradients? 2 pi. Okay, so what we know is we have to add 2 pi to this to get to a coterminal angle. Right? That's just the premise of this. But we're saying for all values, for infinity and beyond. We call this a general solution. So I'll switch back and forth between the language in your assignment, tests, and quizzes. So you need to know what a general solution is asking you to do. So we are going to say theta is equal to, what's the first thing we need? We need our angle. 3 pi over 4. Do I want to use integers, or do I want to use whole numbers?
Whole numbers.
I think I'm going to use integers. So what's the difference between whole numbers and integers?
Whole numbers can be positive,
Mm-hmm.
but integers can go positive, 0, and negative.
Right. So the reason why I say I have to make a life choice right now is because this will depend on what sign I use. So I'm going to say plus. Because I'm going to use integers. What am I adding with full rotation again in radians?
2 pi,
2 pi.
8 pi over 4.
You could write 8 pi over 4 if you want to, but you don't have to. Don't make this harder than it has to be, because we're actually not finding a solution because there's an infinite solution. So how many full rotations am I adding? Here, 1, but the question says forever. We're going to add a
Put the whole
variable.
thing in brackets and then put a variable.
So we're going to say 2 pi k. So 2 pi talks about, this is the full rotation, and k is how many times?
Is that needed?
Yeah.
And we have to state that every time, right?
When we're doing a general solution, we're not done yet. We have to define the restriction on k. K can't be a fraction because you need a full rotation. You can't take, if k was 1/2, would we go around? Would we go around the full time? We'd only go around pi, right? So k has to be where k is an element of the integers. Yeah.
Well, stuff like a weird E.
That E is when we talk about elements. That this type of number is part of this number family.
Yeah,
It's-
write it like that.
I would like you to. I'd like you to practice it. But if you don't, as long as you put the E there, a capital E, you should be good. Okay, so K is the element. So the variable K is an element So k is an element of the integer family. So integers are positive, negative, whole numbers, and 0. Because we want to have full rotations, we can't have decimals. It can't be a real number. It has to be very specific. So k tells us how many times we go around, but we say K has to be a whole number, but can be positive or negative. Pardon? K can't be a fraction, K can't be a decimal. It can be zero, sorry, it can be. Then this would be my angle, yeah. But what do we want? We want all values, right? So we're looking for the infinite answer, and we have to make a domain statement about it.
So can pass K, can the X there?
No, K. K is your rotation number. It's the letter of my first name. Really? Oh. No, this is pretty standard stuff. I didn't pick it because it's Kelly. I picked it, well, I didn't pick it, this is how I was taught it. K usually represents rotation.
Can we use R?
No, R is radius.
R is for half.
Oh.
I'm leaving.
Yeah.
I'm leaving. Okay, if you don't use K, game over. All right, let's do a general solution. Let's do a general solution for 152. I'm going to give you guys 2 seconds to do that.
Wait, we're doing it?
Yep.
This is so easy.
So you're adding, you're going to follow the same model we have there,
So you're trying to create
but what are we adding it to?
360K.
360K. Yes, exactly. But don't forget your 360 has to have that degree symbol on it.
So we're not done A yet?
He's done.
Oh, okay.
I'm asking you to do
Yeah,
that.
if you don't put the degrees symbol on there, you're gonna keep it.
Jonah, he's making a statement to me, not to you.
Yeah, but I never know.
Yes, you do.
That one. How about that one?
Yeah, you know. Give me beans. Give me a one, you know.
Like, we don't need that little two in the E on the very top.
Do I have to
No,
look
sorry,
all
it's
up?
like a fact, it's like a C with
That's
a,
the round.
it's like a very rounded, it's like a C with a line in it.
like an obese E, obese.
If you're having a little possible, what does that E mean? Elements.
Look up there.
Let's go for
So,
That's why.
if, guys, if you don't put the qualifier, so this is the statement about the angle, and then this is the restriction on the variable K. If you don't put this answer is incorrect.
And
Or it's not incorrect, it's not finished. Half point.
does it have to be right after the?
Yes, comma, right after it. This has to be a full and complete sentence. Okay? Yeah, Jonah?
So just that makes, so like when it's like the degrees that you're trying to do, you do 360K, and then when it's the decimal thing,
When it's the radian, 2 pi. Yeah.
What if you use the whole number?
What if you're using whole numbers? That's a good
Or
question.
should, no?
Okay, what letter are we using for whole numbers?
W. Does it matter?
Yeah, it does.
Where you getting the Q from?
Those are, can somebody Google it for me? I never use whole numbers. Can somebody Google the symbol for whole numbers?
You knew about whole
Whole numbers are all positive and zero.
It's a W.
Is it a W? Okay. Are you sure? I don't feel like it is.
you should know this.
I should, but I never use it, so it's not right on the tip of my tongue, and I'm not afraid to say I don't know.
Yeah,
Is it W with Italian?
So Logan, for your question, what would change in this is that I'd have to put add subtract. Okay? So add subtract because you can add whole numbers or subtract whole numbers. Here, I can make k -1, and that's the same action as subtracting. So I tend to stick with the integers just so I can put plus sign and never worry about it again. But if you're going to use whole numbers, then you need to put the subtraction sign. because this is all values, both positive and negative, infinite answers. So it's gonna have the plus minus on it.
And it's gonna be a W?
It will be, and then you have to have this. If you use a plus minus, you need a W at the end. If you use just a plus, you need an I at the
Is
end.
it possible just to use that minus?
No, because then you would be ignoring all the positive coterminal angles. And we're looking for all infinite values.
So is the top one wrong?
Nope, the top one uses integers,
Keep in mind.
and it's just a plus sign.
So, could you use all negative, if it just says like, all like,
I would expect that whatever restriction I give you,
yeah,
you guys will have enough math knowledge to make that decision whether you should be using a positive or negative number for it. I'm gonna tell you honestly, I'm probably gonna ask for just a general solution, and you need to go from there.
What about?
I don't think they would, but I can totally see a question like this. I can totally see a question like this, and I can totally see this question on your test here.
But Sally, did you just predictably kind of do?
No.
Why not?
You grew up in this world? Okay, I need you to reach back into your brain. Dig deep, second semester, last year.
Oh, reference.
Flashback. Reference angles, do you remember the rules?
Yes.
Okay. So in quadrant one, because remember we have two answers for everything. If you look up sine 0.5 in your calculator, it's getting your second function sine 0.5, you'll get an answer of 30 degrees, but you guys know better than that now, that it is also 150. Right? You guys remember that?
No. Yes.
Do you guys remember that from your Canadian calculator? So if you use your calculator right now, and do second function sine of 0.5, you're going to get an answer of 30. If you're in degrees. If you're in radians, in different colors.
Oh, that's what that means.
RAD Canadian.
I thought that was simple.
Do you remember the CAST rule?
Nope.
You do. Well, if you don't, get in touch with it. It tells us what trig ratio is positive in each quadrant. In quadrant one, all of them are. In quadrant two, sine is. So your calculator gave you the answer for quadrant one. That's all it knows. You need to be smarter than your calculator and say, hey, there's a possibility that there is an answer, but it would be only in quadrant two, because that's the only other place that the sign is positive. So we would use the rule for quadrant two to find the other angle.
Where do you want to eat from? Why did we do that?
Because quadrant two has the angle 90 and 180. Makes it act.
So we proved these in grade 11. So, I appreciate that some of you might not, that was a million years ago, I totally get it. I'm not going to take the time to prove it now. I will ask you that if you put sine of 150 in your calculator, you will notice that you get a decimal answer of 0.5. It's a true statement, it works. We did a whole lesson on this, proving this in grade 11. Go back, watch the video. No? I'm really excited with that. Okay, so all of this is great. But now we don't just live in degrees. We have to change these rules to include our radian option as well. So does anything change in quadrant one? Theta is theta reference, easy peasy, there's no values in there. What would the rule be using radians for quadrant two?
Theta equals to pi minus
Pi minus theta reference.
pi minus.
That's not what you said, you said 2 pi. And those are very different places, right? 2 pi and pi are very different places. Pi is 180, 2 pi is 360. So that would be, we're just translating this now into radians. So this one's going to be theta is equal to pi plus theta reference. And this one will be, what's 360, Rahat?
2 pi.
2 pi. Okay? So nothing's changed there. We just translated it into a different unit of measure. This is all grade 11 stuff, but now it kind of ties into grade 12, so you need to know those things. Okay. You ready? We want the reference angle for 11 pi over 6. First of all, we've got to figure out what quadrant we're in. Okay, so you guys need, this is where like the memory thing kicks in. So this is pi over 2, that's pi, that's 3 pi over 2, and that's, let me erase that. That's either 0 or it's 2 pi. It's either where you start or where you finish. Okay? What quadrant am I in?
3, 4.
Pick 1.
1.
I'm in 4. I'm in quadrant 4. Does everybody know how to do that?
Oh, I figured it out.
Did you figure it out? So if I wrote 2 pi with a denominator of 6, that would be, we did this already, 12 pi over 6. What would this one be? 9 pi over 6. This would be 6 pi over 6. This one would be 3 pi over 6. So where does 11 live? It lives somewhere between 9 and 12. So we know we are in quadrant 4. Okay? So those common denominators, the things that my grade 9s are struggling with right now, I wish you guys could come in and tell them that this won't be, like grade 9 isn't terrible. I might need some motivational speakers. Not really feeling the squeeze. Do you guys remember where you were in grade 9 math class? Felt overwhelming a lot. No, just was like no big deal.
Well, like,
It's very quiet.
Very quick. See, I was in my MMA block. Like nobody's awake, nobody's speaking to each other. Okay, what's the reference angle in quadrant 4? What's the rule?
Stop looking at me, I'm gonna get mad, like, excuse me.
Okay, theta equals 2 pi minus theta reference. Do we have, is this, we're solving for theta reference, right? We're asking for the reference angle. So where does 11 pi go in? Does it go in the front or in the back?
In the back.
Front. Because it's theta. We're looking for the reference angle. Now you could rearrange the equation if you want. That's probably what I would do. So really theta reference is going to be 2 pi minus 11 pi over 6. I forever want to put a pi symbol over the number 11 and I'll like have a pi and I'm just going to pay attention to it. So what's theta reference? Pi over 6. Okay. Well, I brought this to the other side, so it changes to a positive. I brought this to the other side, so it changes to a negative. I'm just not showing that map, so.
So, I got lost in, like, how's it collect for again?
Okay, so what I did is I took my values on the coordinate plane, and I made them all denominators of 12,
Oh, yeah.
right? That's just rude, man. That's just rude. didn't know your phone was on? The guy holding it, watching reels, didn't know his phone was on? Oh, okay. All right. Next one. Where on the quadrant plane are we?
Quadrant 3. Quadrant 3.
Okay, you guys know you're going around negative, right?
Quadrant 2.
It's gonna be, you've got.
Yeah, quadrant 2.
Okay. Okay. For those of you who are thinking about it, we know that sometimes seeing it in negatives is really hard to see. We know that we've gone around more, like you change 4/3 to a decimal, you get 1.3, negative 1.3 repeating. So we know we've gone around at least 1 pi. So if I'm traveling in the negative direction, I know I've gone around at least there, right? And then I'm going a little bit past that. Hey, you need to stop with the water bottle. No more water for you. None. Or leave the top off.
He's gonna die.
Okay, I told him he can still drink out of it. Just leave the top off.
She's not so scared.
Yeah, that's what I was going to say. So the negative 1.3 just means that we've traveled 1 pi already, so that's 1 pi, and we're here. Now, I don't do really well with negative angles because I've lived my life with positive angles. I'm going to find the positive coterminal angle of this. That's why coterminal angles are handy. Can you guys find me the positive coterminal angle of this?
2 pi over 3.
I think you're right. I think he's right. So if that doesn't help your brain, doing the positive coterminal angle would be super helpful. So how do we find a positive coterminal angle? We're going to add a full rotation. So what am I adding? I'm going to add 2 pi, right? I'm not going to add 360 just because we're not in degrees. I'm going to add 2 pi. Okay, so by adding 2 pi, I don't want to add 2 pi. I'm going to put that in common denominators. So I'm going to be adding 6 pi over 3. And Rahat told me that that was going to be 2 pi over 3. That is a positive coterminal angle. These end in the exact same spot. 2/3 is greater than 1/2. I'm in quadrant 2. I was in quadrant 2 when I went this way. I just don't like dealing with negative rotations. That's just not who I am. So I'm going to use a positive coterminal angle to help me better answer this question. So what's the reference angle? No. So this was my positive coterminal angle. Using this, I'm going to use the rule. What quadrant am I in? 2. Quad 2. What's the rule for quad 2? Let me scroll up. 180 minus theta reference. Is this my angle or is this my angle reference? Just angle, right? That's the given angle. The question's asking me to find the reference angle. So I'm going to have 2 pi over 3 equals 180. Oh, where am I? Minus, no, why am I doing 180? That's not helpful. I'm in radians, so it's going to be pi minus theta reference. Can you guys solve that? Can you solve it in your head? What would this be with a common denominator? 3 pi over 3. I'm going to be subtracting 2 pi from that. So theta reference is pi over 3. So I asked you to do a lot of math, and I asked you to visualize the rearranging of the equation, and I asked you to do the common denominators in your head.
Where did you get 3?
Okay, change this to a common denominator of 3.
When you, like, divide everything.
not divided.
Pretend there's a one in front of the line.
Pretend there's a 1 in front of it, 1 over 1.
Right.
Oh, and a common denominator of 3, what is it now? What do I multiply 1 by to get it to 3? So, I'm going to have 2 pi over 3 equals 3 pi over 3. Sorry, I'm going to move here. Just get a little sketchy. Rearrange the equation. It's just basic algebra. I'm adding theta reference to both sides. I'm going to minus 2/3 pi by both sides. So I'm going to have theta reference left on this side, 3 pi over 3 minus 2 pi over 3. And that's where I get the pi over 3 for the answer. I asked you to do that all in your head. I would do it on a scrap piece of paper. I probably wouldn't show that, but if you need to, definitely write down your steps. There's no shame in that game. You just need, and especially when you're doing a math exam, when you've been sitting for, you guys did this last year, like the math fatigue that kicks in. You know the math, but I'm asking you to give all the math all at once. So putting in a safety net isn't a bad thing to be fair. Okay, so this is where things get complicated, and this will be on your quiz, and I find students have the hardest time with this. It's not a hard concept once you get it, but it takes a minute to figure it out. Remember that coordinate plane we had? 0, 2 pi, pi over 2, pi, 3 pi over 2? You guys remember that from the question above? Those ones you really like, I don't know, that's what I said, leave room on your forearm for the unit circle for your tattoo. This is important. Well, it's going to be helpful. Is it life important? Maybe not, but it's super going to be helpful for university and for this course. Okay, what quadrant is this talking about? Figure it out. Like, you're just saying quadrants. Like, so first of all, where am I between? Theta has to be, oh, this doesn't work. Sorry guys, this should be in the other order. This is confusing. That's why Jonah was confused. It's because we're all hot. Okay. So, theta has to be less than or equal to 3 pi over 2, but greater than 5. So really, look at those two numbers. Where do we see them? Pi and 3 pi over 2. Where are you? Quadrant 3. So this restriction says my answer has to be in quadrant 3. My answer has to be in quadrant 3. That restriction is telling me I must only work in quadrant 3. All right, I have given you the reference angle. What is the actual angle we're trying to find in quadrant 3? What's the rule for quadrant 3?
I plus pi divided by 4.
No, because theta has to be less than pi, but greater than pi over 2. He was right, I needed to move it. Okay, so the rule here is in quadrant 3, 180, which is pi, plus theta reference. What have you been given? You've been given, but is that theta or theta reference? Theta reference. It's asking for, given the reference angle, so you've been given the reference angle, find the angle. So theta is equal to pi plus pi over 4. Can you do the common denominators in your head?
Yes,
Yes.
2 divided by 2.
No,
What's the answer?
five.
5 pi over 4.
Literally just said three.
Well, we got an insight to your thinking. Okay, what quadrant is the next restriction in?
The quadrant two, quadrant three, and quadrant
It's only ever going to be in one quadrant, quadrant 2. Your theta has to be less than pi, so it's got to be less than pi, but greater than pi over 2. So that is somewhere in there, quadrant 2. So this is telling me my answer's in quad 2. Oh, maybe this is the one we had tons of problems with. Okay, so rule, again, theta is equal to 180, which is pi, minus theta reference this time.
Oh, I misread pi over two as pi.
Oh, okay. Can you do that in your head?
No, you do something
Get a common denominator here.
that.
So 6 over 6, right? And 6 divided by 6 is
What's that?
1.
5 pi divided by 4.
5, 5, 6, yeah.
I knew it.
Oh, write this down.
It's just sitting there.
He's just, now he's got it now. He can do common denominators. Just play. There you go.
It's really difficult.
Okay, so now you have all the knowledge to do this one assignment. Isn't that nice? One assignment? 2 days, one assignment?